I hit the wrong button. I stopped recording instead of pause or restarting it. That's okay. Okay, this is gonna be 2 parts. All right, so for this equation here, we need to rearrange this so that way it is now set to equal to n. The way I do that, if you guys are not algebra inclined, is c equals n divided by v. In order to get rid of v, I would then times it by v on both sides. The v's cancel out, and I get n equals concentration times v. So I hope you guys got that. If you don't, then you need to work on your algebra. All right. Let's plug in the numbers then. So n is equal to my concentration, which I have gotten from question 2, and even says on the question, hint, this is the answer for question 2. So it snowballs. If you make one mistake, it snowballs. So let's not make any mistakes. All right, so I'm using that number here. That's the 0.042097836, and that's moles per liter. And then I multiply it by the aliquot size I used. So we have to be mindful of what numbers we're grabbing. We're grabbing this number instead for volume. Hopefully you guys got that too. Remember that this is in milliliters. So again, we need to convert it into liters. So divide it by 1,000, 0.025 liters. The liter should cancel out and you are left with moles, which is what we want. So again, if you haven't cleared your calculator, it's useful because you don't have to retype it. My calculator went to sleep, so I do have to retype it. All right, and I multiply that by, let me show you guys what I'm doing. Multiply that by 0.025, hit enter. And so what that tells me, and you can see how a lot of people ask me what this means, the -3. So 2 different ways you can write it. It either means that you have 1.05244459 times 10 to the -3 is one way you can write it. The other way you can write it is that it just means that the decimal place moves over 3 points. So if I was to move it over 3 points, it would be 1, 2, 3, and I would then have those 2 zeros in front. So that's what the -3 means. Okay? Both are correct. I will accept both answers. In this case, there's nothing that states I have to round it, so I'm going to leave it unrounded. And I have 0.00105244459 moles. So if I took a 25 ml sample of that acid, that is how many moles of sulfuric acid that I'm working with in my equation. Are we good so far with that? All right, next step then is I need to check my ratios to figure out how much base do I need to neutralize that acid. Something to keep in mind is that there's a 1 in front of the sulfuric acid, even though it's not written, it's assumed. And it says that there's then a 2 for the sodium hydroxide. So what that tells me is ratio-wise is that for every 1 mole of sulfuric acid that I have, I need to have 2 moles of sodium hydroxide to neutralize it. Okay, so if I know that my value of sulfuric acid is this, I need twice as much base. So 0.00105244459 times 2. There we go. All right, if the numbers were reversed and this said 2 and that said 1, then I'm dividing it by 2. Hope that made sense as a quick little note. Just ratios. All right, so let's times that by 2 times 2, and I get 0.0021048918, and again, I love my units, mole. So that's how many moles of base I need in order for this neutralization to occur. Mole? I was like, really? You got me the lesson. Okay, it is recording. Make sure you watch it. All right, keep going. Okay, now we're on to this page here, and we are going to start using the same equations we were using before, except I now need the volume of my base. So I'll give you guys another break because I'm mindful this is going to be a very long talking lesson otherwise. I want you guys to calculate what the tie tray, and there's a typo here that should say tie tray, not tire, volume. So you need to do the quick subtractions here. For it, do not do the averaging yet because I want to talk about the merit excellence criteria, the merit criteria for that. All right. So first off, just do the subtractions and I will show you what I need for the averaging. Okay? So give that a go. So I don't muck this one bit, and let me unfreeze the screen. There you go. Okay, those are the numbers I got. Do you guys have the same numbers? It is just a subtraction. All right, some things to note when we're looking at these values is you have initial and you have final. So initial is what I read off of the burette before I start titrating, and final is what I read after I finish titrating. I then do the subtraction to figure out then what my volume is. When you are answering these questions, make sure you have not two significant figures, two decimal places, because we know when we're looking at our burette, we can give a rough estimate if they are on the line or between the two lines. This is actually not a good example because they put the number like 8.3 and really should be 8.5, but it is what it is. We'll just leave it. All right. Something else you can see is that this one's final volume of 18 is being recycled for titration number 4 because basically I'm starting it from the last one. So that's useful when you guys are doing it. So you don't have to refill it each time. That's what I want to remind you. All right, something else to keep in mind. Let me pull up the marking schedule so you're aware of it. And let me zoom in so you guys can see it. All right, something that is required for the merit and excellence. So it's a merit requirement. So in order to get excellence, you need to get the merit anyway. And that is the range. So the range needs to be within 0.3. And let me unpack what that means. So 0.3 needs to be your range. So when we have that range, the reason why we have it is because we want to make sure that our data is precise. We want to make sure our data points are close together. So let's make sure that our data is precise. In order to calculate if my range is within 0.3, I need to take my biggest volume of titray and subtract away my smallest. So we figure out range by taking biggest, titray, volume, minus the smallest. So when I look at this guy here, 17.2, that one is my biggest. So I'm just going to write a B next to it. And then my smallest one is 16.7. So if I did the subtraction between these two values, 17.2 minus 16.7, I would get my range is 0.5. So if you averaged all 4 of those numbers together and you didn't exclude a data point, what's going to happen now is you are going to go down to an achieved. Regardless of if everything else is really good, if you do your really good write-up, it's going to be marked down from excellence down to achieved because you are not excluding data that isn't within your range. So what I now need to do is I need to decide, do I exclude my smallest value or do I exclude my biggest value? So we'll do a couple of checkpoints just to see how it adjusts. So let's say I exclude this one, then my new smallest value is going to be this guy. So that's now my new smallest. So if I did that math and I did 17.2 minus 16.38, my number is 0.37. So the range between these two is 0.37. So that doesn't work. So let's do instead, I'm just trying to grab more colors. Let's say I eliminate this guy instead, which is my biggest, and now my new biggest is going to be 16.9. Newbie. Okay? Then what I would do is I would do 16.9 minus 16.7, and my range is now 0.2 milliliters. So I'm happy with that. So what that tells me then, if I'm going to exclude one of my values for averaging, it's going to be this one. You only need to exclude numbers if it's not within the range of 0.3. It's also when you guys are doing your titration, you're collecting your data, you can have a look to see how your data is going. And if you have a bad data point, you can just exclude it and do another titration. Okay? Then this one here is average the 3 concordant titrates. So when we see the word concordant, that is referring to that 0.3 milliliter range. And the other thing is they want us to do 3 significant figures, including our units. So this here, if you look at the requirements, which is really nitpicky, is the excellence. So if you see on excellence, it says consistently uses 3 significant figures and units in questions 5, 6, 7, and 8. So specific parts of this assessment, for some reason, the requirements state that I need to look to make sure you know how to use significant figures and units. So just something to keep in mind. So let's average those 3 numbers together. 16.38 plus 16.7 plus 16.9. Be mindful that if I was to do this in the calculator and then I just hit divide 3, only the last number is getting divided by 3. So just watch out on what you're doing. So I'm going to add it all together first or use brackets, divide it by 3, and now I have my value. So let's just write that in. So we had 16.38 plus 16.7. And make sure you show all your working so that way it's very clear that I know what you have included and excluded. Divided by 3, and I get my answer to be 16.81. Now, this asks to have it in 3 significant figures. So it's not 3 decimal places, it's 3 numbers. So 1, 2, 3. That's 3 sig figs. 8 is my last number, so I look over to the number next to it to decide whether or not I round up or round down. It is below 5, so I am rounding down. So my answer for this one is 16.8 milliliters. So again, the 3 figures and the units will influence whether or not you get your excellence. So if you just wrote this number down, you would just be getting merit. I don't know why, but that's just the deciding factor. It's very strange. All right. Questions so far? Or keep going? All right. I think this is our last step. So our last step now is to calculate. So now that we have the average titrate volume and we know the amount of sodium hydroxide we need, we can figure out the concentration of the sodium hydroxide. So again, C is equal to N divided by V. I'm getting the N from question number 5, which is this guy over here, that number. And I'm getting the V from, question 4, and then I'm getting the volume from question 5. So C equals 0.0021048,918 moles, and then I divide it by my volume, which is 16.8. If you want to use the unrounded value, that's also fine. I'm not going to be a stickler on that. Either or is fine. And then we plug it all in. 0.002104818 divided by... Oh boy, I already made a mistake. I forgot to convert that into liters. There we go. Now that's in liters. You guys see what I did? Okay, don't do that. Cool. And my concentration is actually, let me show you the big number. 0.125216644 moles per liter. But I want to have it, again, it says 3 sig figs, including units. So 1, 2, 3. We actually don't count that 0 there. That's just a placeholder. So I look at the 5, go over to the 2. 2 tells me to round down. The 0.125 moles per liter. And that's what I've confirmed my concentration for the sodium hydroxide to be. And we were expecting it to be 0.1. So what that would mean is I would need to adjust the concentration of my sodium hydroxide, which means out. And that's why we double check. Questions, concerns, comments? All right, the good news is that Part C calculations is more or less the same. It's just in a slightly different order, but same methodology. So things I want to point out to you guys so you know what to do to kind of help you with your study. So Thursday we will do part C, and you guys will actually collect your data, and then we'll work through the calculations. I'll let you have a go at calculating before I tell you the answers. For practice, I suggest doing these SciPad pages because it does go over what the mole is. It does practice using that conversion from moles to mass. It also does do the concentration as well. And what I've done as well is on Google Classroom, and on my Google site, I should say, I have uploaded practice assessment style questions. So let me just open that up. So where is it? Oh, here we go. Practice part B assessment style questions. I also have the answers so you can check it. I haven't printed it off because I'm trying to save paper. But if you look here, it'll all be online so you guys can do more practice like that. See? It's the one that I was using as my exemplar. Oh no, I have different numbers here. Yeah. I have different numbers. I don't do we have different numbers. Okay. So you have all those practice questions to do. Here are some different numbers. So you can see this one's a 1-to-3 ratio. So lots and lots of practice for you guys to do. Right? Do the practice, hand it in to me, so that way I can take notes that I've seen it. If you make a silly mistake on the actual assessment and you've given me additional evidence, I can say, I know this is a minor error. They've given me other evidence to show that they do remember how to use significant figures. So it's always a good backup. Alrighty, cool. We've done that. And then when I see you guys next, we will do part C.